Yes, you can. Yeah, guys, for these, because the question was written in ratio form, right? They say show that AD 2 dB is equal to this. You can write everything else in fractions. That's perfectly fine. So you could have written AD over dB is equal to CE, over EE. And the other one, your final line, the two fractions equal. But then, guys, your last line in the question has to be this. Okay, because that is what they asked you to prove. So please, even if everything else is in fractions, your final line has to be written with ratio. Any other questions on these three questions? Okay, moving on to number 8. Now, number 8 was the first one where you really had to kind of like figure out what was going on. It was quite tricky, so I'm just going to show you quickly. What I did on the side is I just wrote, this is actually just for myself, I just wrote which triangles I was working with. But guys, this can be quite useful if you're doing it in a paper exam and you're worried that you're going to like lose track of what you're doing or where you're working. It is quite useful to just write like on the side, just which triangle you're working with. So, okay, they wanted us to prove this, right? That GB to GD is equal to GD to GC. Oh, that's confusing. Okay, so we needed to prove these two. Now, guys, it's a big hint, the fact that there's so much going on, right? There are so many triangles and multiple pairs of parallel lines. That should tell you already you won't be able to just immediately say this is equal to this. So you're going to have to work with like an in-between step. Now, obviously, this looks very simple, but because there's so much going on, it is a bit confusing. So, first, I tried to just find GB to GB. And again, you could write it in fraction form, that's fine. And I tried to see, is that equal to something else? All right. So, I looked at triangle BFG. I'm going to actually just put it in here for you, and then I'll take it away. So, this triangle, right, that was the first one that I looked at. Now, these two lines are parallel, right? So if we're doing GB to GD, that's the whole side over that part. That would be GF to GE. Right? You guys agree with that? Okay, so that was my first one here. I'd rather do that blue guy. Okay. Actually, sorry. Here we go. Okay, then I said, okay, now I have GF to GE. Now, if I want to prove this whole thing, GF to GE has to be equal to the other half of what they asked me to prove, right? So then I looked for GD to GC. So if we're looking at GD and GC, that's supposed to be outside of the triangle that I'm going to work in now. So guys, this one was a bit more difficult to see. I worked with that triangle there. Right, that small triangle there. Because they put the parallel symbol in this part, but guys, this is one side, right? So this AE part is parallel to that. That means that those two lines are actually parallel. So it is quite useful to literally like cover up what you're not looking at. Do we see there GF to GE is going to be equal to GD to GC, right? GF, oh, sorry. GF to GE is going to be parallel to GD. Not parallel, equal. So I'm clicking on. Okay, so the key actually is to find that in between fraction or ratio, which in this case was GF. Okay, and guys, if it helps, literally like take your pencil and like color in, shade in the triangle that you're looking at. All right, erase that, shade in the new triangle. Okay, it makes it much easier to actually like physically call it a triangle. Any questions? But if you at least get one half of this correct, you'll get a mark, okay? Like you don't have to do it's just like math, you don't have to have everything correct to get any mark. You might get a mark there, reason. Is that it? Sorry. No, no. What was the one? Okay. Well, find it up on guys. Can you read? Okay, then you had to do, was it 5 and 6? What's on the next one? Yeah, 6 was difficult. I didn't go. Oh, I just like interesting. I would like to know. Okay, number 5. Again, guys, your steps don't have to look exactly the same as mine, but I think they probably will. Okay? So what I did here, again, we have more than one triangle, but I think this one is a bit easier to see than the triangle in section 8. Because if you're looking at these two parallel lines, you can say, okay, I'm working in that triangle. You look at those two parallel lines, you look working in the whole big triangle, right? So for the first one, they wanted us to find the length of QR, which is this side here. Right? They wanted us to find that length. So what I thought was, I need to, there's a lot missing there, right? We don't know what QS is, we also don't know what TR is. So I decided, okay, let me look at this triangle here. Do we agree that we can calculate TR quite easily if we're working in this triangle here, right? Because we have those two parallel lines. So TR over 12 is going to be 22 over 24. Okay, so that's what I did for the first one. Top theorem, PS parallel to DC. Okay, with TR on its own, you need to multiply that fraction by 12, and you will get an answer of 11 millimeters there. Okay. Yes. Now we need to find QR. Now, guys, some of you might have calculated QS and then added it to 23, which is fine. I just thought, let me do the whole side. So now if we're looking at the big triangle, right? Sorry, I don't know why I was thinking of it. We're looking at the big triangle. QR is the whole side. And on the other side, the whole side is PR, right? And we have that length. That's 36. Now we're looking at these two lines that are parallel. Let me just pull them in. That one is parallel to that one. Okay, so if you're doing QR over that part, which is 23, so the whole over the top part, that's going to be equal to that whole over that top part. Okay, so QR over 23, which is that, 12 plus 11, is equal to the whole, which is 46, over the top part, which is 20. And then we need to do that. All right, any questions? All right, number 6. So I did mention in class the other day that you have to use a property of you need to use the fact that it's a parallelogram to be able to do this question. Unless someone found a different way of doing it. So guys, does it say anywhere that it is a palm? If you read through the little heading, whatever, they didn't actually, right? But we can see that it would be because that side is parallel to that one and that side is parallel to that one. So I wrote down PQR is a parallelogram, and then you are allowed to use this symbol in finals. I mean, that's fine. Because both pairs of opposite sides are parallel. You have to say that, guys. Alright, if it wasn't explicitly given that it is a parallelogram, and you want to use the property of it, you have to first write that. Just remember that. So because of that, do we remember the main property of the diagonals of a parallelogram? They bisect each other, right? They're not equal in length, but they do bisect each other. So that means that, and I didn't actually fill it in on the picture here because there's a gap there, but that means that this PO is going to be equal to OR, the whole side. And whenever you're using any property of the diagonal in any shape, you don't have to say exactly, you don't have to say that, diagonals bisect each other. You can just say diagonals of whatever the what is. Alright, parallelogram, rectangle. So guys, you're probably gonna have to go over those properties again, right? I don't know if you all remember them. Yeah, we haven't really used them in quite a while. what they did give us was that QB to BR was 2 to 3, I think. That's what they said, right? So I called in a 2x and a 3x there, just to remind me of that ratio there. Remember, guys, please, you can't say 2 and 3, because then the marker is going to read that as 2 units and 3 units. Okay, and that's not necessarily the case. So if you want to fill the ratio in on your picture anyway, you have to write it with a variable attached to it. Okay, so it can be 2a and 3a or whatever. I did 2x and 3a. Now, guys, do we see this triangle here? Yes. Right? Do we see that this line, because it's an extension of OS, this line is parallel to that line? So if that's 2 to 3, this is also going to be 2 to 3. Okay, do we agree? Okay, so we can fill in. Now, guys, the thing here, you can't put 2x and 3x in. So we haven't actually done an example like this before. You have to then say like 2y and 3y. Because if you're saying that this is 2x and that is also 2x, that means that these two parts have the exact same length. Right? So if I'm saying this is 2x, then 2x is exactly the same. So say that's 4 units, that's also supposed to be 4 units. Okay, and it's not going to be the same length. The sides are just going to be in the, or the lines, the parts are just going to be in the same proportion. Okay, so that's something to look out for. Sorry, we haven't actually discussed that yet. But if you are doing that on the diagram, you can't use the same variable on both sides. Okay, you have to use different variables. Otherwise, you're saying that the sides are literally the same. Okay, and they might not be. They might, but they might not. Okay, so now here, what were they asking us to prove? PO over OC. That is what they're asking us to prove. Now, what I said here is that PO over O, where's C now? Oh, is that C there? I didn't put it in, sorry. Okay, what I said is that PO, so I started with what they were asking me. Okay, PO over OC. Now, because PO and OR are equal, do you guys see what I did? I just replaced PO with OR. Okay, because PO and OR are halves of that. Okay, so that's all I did. In my first line here, I didn't actually use top pyramid. I just replaced PO with OR because I know that they're equal. And that helps, guys, because OR and OC, if I'm looking at this fraction, are actually in the same ratio as QR and QB. Okay, because of top here. If you're looking at PO and OC, those two lines, right, are not in the same triangle as this, where they gave us the ratio on the outer side. All right, so again, I replaced PO with OR because they are equal because of the parallelogram. Then I use Theorem to say that OR, so the whole, over OC, that part, is that whole over that part. So 5 over 2, right? And that's actually what they asked me to prove, I think. Yeah, but that is tricky, guys, because like I said, I don't think anyone's mind was on properties of quads when you're looking at it. Okay, but you do need to get used to, obviously, they mix the topics together. So we do need to, kind of try and remember everything at once, which is a tall order. Getting to that point now. And before I forget, Mrs. Court said that she was going to close sign-ups for that worksheet book by Thursday, but she actually said that she'll still accept names today. So if you have forgotten to put your name on that list, or if you still want to, then you can do it today. So. Okay, any questions on 6? Difficult one. Right, 6 is definitely the most difficult of all of these. And then number 8 from the previous question, I think also was quite difficult because there was a lot going on. All right, we're going to do that quiz now, guys. So if you can please either stick that into your books quickly, or you can just write on top of it and stick it in later. That's what we prove what's going on. Given that the required proof and the construction Okay, guys, let's keep going. So this proof, this proof looks like this. So what I've done here is we're going to put our constructions in now, you'll see, and then the constructions are actually going to divide that picture into these three sections. And each line in the proof is referring to a specific section. So I thought that it would be useful if you could actually have the sections drawn separately. But guys, when you are doing a proof, you're just going to write the written stuff. Okay, you don't have to draw these pictures. You don't get marks for this. This is just added in by me so that you can hopefully understand it a bit better. Okay, so you're never going to have to draw these pictures here. Okay, so we know by now what the prop theorem is saying, that a line drawn parallel to one side of a triangle divides the other two sides proportionally, and we know that that means in the same proportion. Okay, so given, that's obviously what will be given. So that same picture that I wrote, or that I drew, sorry, the first day, we're going to give you a triangle. So guys, we know with proofs, they can change these letters. Okay, so they might not give you triangle ABC, they might be like PQR. Okay, so just be aware of that. With point D on AB and point E on AC such that DE is parallel to BC. Okay, that is the basic thing of this theorem. You can't use this theorem if these two lines are not parallel. So that is what will be given. We have to prove the prop theorem, which is what we've been using this whole time, right? So we have to prove that AD over DB is equal to AE over EC. Okay, that's what we're going to prove. Now the construction, guys, this is the first, maybe they might ask you to fill that in, so maybe let's just highlight that because I've obviously already filled it in for you, but you could be expected to fill that in, the required to prove part. And then you will definitely be expected to fill in the construction. Okay, so highlight that as well, please. You're going to have to memorize this. You will have to be able to write it down in words and then show it on the picture. Okay, so we're going to draw it on the picture together now. So they're saying construction is altitude H and K of triangle ADE from E and D. Now guys, what is an altitude in? It's a perpendicular line. It's going from one vertex and it's perpendicular to the opposite side. Okay, we did that last year in analytical geometry. So they're saying of triangle ADE from E and D. So guys, we're going to draw in two perpendicular heights essentially. All right, so we're just going to call them H and K. So let me just show you here. Maybe if you have two different colored pens, it would be nice to do the one in the one color and the other one in the other color. So H, I'm going to draw from point E. Now just see, guys, you're going to have to try and draw it so that it's perpendicular to AB. Okay, we're drawing in the perpendicular heights of triangle ADE. So just this top triangle. Okay, we can ignore that bottom part for now. So just try and draw it in so that it looks like it's perpendicular there. Is it better? And do that on H. Yeah, I just can't do a dotted line on here, but you can do whatever. Normally for constructions, we do dotted line after it. Sorry, I can't draw a dotted line with this program. So if you're using a different color, it doesn't have to be dotted. And now, guys, we're going to do the same thing. We are again going to draw the perpendicular height of that same top triangle, but now we're going to draw it from point D. So from here, and now it's going to be perpendicular to AE. All right, so now I'm going to use a different color for that. I'm going to do green, I think. So now again, just try and draw it so that it looks like it's perpendicular. I'm not sure about that. And the second one, we're going to do yeah, it's a bit, a lot of students. A lot of the ideas. That's rude, Robin, please. Okay, next thing, there is a second, well, actually a third part to this construction. We are also going to draw in lines DC and DE. So this is now where the bottom part comes into play. Now we're going to draw in DC, which is there, and BE, which is there. Okay. Now what I want you guys to do, if you use different colors, please draw BE in the same color as H. Just for your, yeah, because we're going to work with that shape there. And then you're going to use the same color as K for DC. So guys, once you've done that, if we look at this top part, now for me it's the blue section basically, right? You see that that is the first shape that I drew at the bottom as part of the proof. So guys, whatever color you used for this one, for A, B, E, please just outline that A, B, E in that same color. Or color it in if you want to. Yeah, so that's the H, whatever color you want for H. This is quite complex. It's actually not that bad if you look at what you have to write down. But yes, the fact that there's so many doors, that's very familiar with the time. Okay, guys, now what I've written there, you are also going to have to remember, right?
Right.
Thank you. What I've written, what I've written there on the side, you have to remember that as well, right? I filled it in for you, but this is a part of your proof. So now what is this saying? Area of triangle ADE. ADE. Now guys, it's maybe a good idea to just draw in H as well. Yeah. Just draw it in. What we are going to do now is we are going to actually write out. If you had to calculate the area of triangle ADE, what would you write? How would you calculate that? You would say ADE, the top one. How do you find the area of a triangle? Half base times perpendicular height. They don't. They have the same perpendicular height. So we're going to say half times, what is the base of ADE, guys? Remember, if we're talking about base and perpendicular height, the base can actually be any of the three sides, right? But since we have that perpendicular height, we have to choose AB as the base. Okay, we can't choose BE. BE could also be the base, but we don't have a perpendicular height for that one. Okay, so we're going to say half times base, which is AD, times perpendicular height, which is h. Now we're going to do the same thing for triangle BDE, which is the whole triangle. But guys, do we agree that h is also the perpendicular height for BDE? Right? It's also the height from the base, which is going to be AB, to the top vertex. Right? So the area of triangle BDE is also going to be half times base, which is now AB, times h again, because it has the same perpendicular height. Oh, it's not. Oh, sorry, it's not the whole triangle. Oh, dear. Okay, sorry. It does have the same base, or the same height. BDE, sorry, is this one? Yes, okay, my apologies. So the base is BD. Thank you. But guys, do you remember, I think the last time you saw these types of examples was like in grade 8, where if you have a triangle, I'm going to try to turn my page so that you can see it. We're looking at this side triangle here, right? That one there. Do you agree that the height is still that h? Right? It can't fit in the triangle. So now looking at this one here, let me fill it in for you, this bottom triangle. So you guys don't make the same mistake as me, that one there. The perpendicular height of the triangle is always the distance between the base and the top vertex. So the base is now BD and the top vertex is E, right? So that height, that actual distance, if you had to measure it, it would still be h. Okay, does that make sense? Even though it doesn't fit in the triangle now, it can't because this is an obtuse angle triangle, but it still has the same height. Okay, sorry about that. Okay, but are we fine there? Kind of. All right. So guys, what do we have here? We have a half and a half that we can cancel out. And we have h and h that we can cancel out. So this ratio here, we can actually simplify to just AD over BD. And guys, do you notice that this is the first half of what we are trying to prove? All right, let's go back up. Required to prove AD over BD. Right, we've done one half. Now we're going to set up the same thing so that we can get that half, but then in our third step, we still need to prove that the two are equal. Okay, so next up, this is now the triangle that we are going to use K for. So I made my K green. So whatever color you used for K, if you can just put that in for this triangle here. And then if you can also draw in your K. Okay, we're going to do the same thing, guys. Again, we're going to take the area of the top triangle over the area of that bottom smaller triangle. Okay, so the area of the top triangle again is ABE, but now because this is our perpendicular height, the base is going to be AE. Okay, so we're going to say half times AE times the perpendicular height, which we made equal to K. And now, again, the area of this bottom triangle, let me not get it wrong again, this one here. Now, what is the base of that bottom triangle, guys? It's going to be CE, but it's going to have the same perpendicular height. Okay, because that distance between the base and the top vertex, E, is going to be K again. So that area is going to be a half times CE times K again. Just like in the previous step, we can now cancel out the halves and we can cancel out the K's, and we are going to be left with AE over CE, which is the second half of what we are trying to prove. Guys, I want you to notice that in these two fractions that we started working with, you see that we have the same triangle at the top. We have area triangle ABE at the top here and area triangle ABE at the top there, right? So we already have that the numerators must be equal. But now what about the denominators? Basically, what we're going to have to try and do, guys, is we're going to have to show that this whole fraction is equal to this whole fraction. Because then these two fractions will be equal to each other. Okay, now these two fractions are already quite close to being equal because, like I said, we have the same thing at the top. We have triangle ABE and triangle ABE. So what we now need to do is we actually have to show that the areas of these two bottom triangles are equal. Okay, because if I can show that the area of triangle BDE is equal to the area of triangle CDE, then this fraction is equal to that fraction. Okay, now for this part, please draw in your lines that you did here. So my one was in blue and the other one was in green. Let me just check. That one was blue and this one was green. So now, in order to prove these two triangles, the area is equal, we're just going to look at the bottom part of that diagram. We're not looking at that top triangle anymore. Now, triangle BDE for me was the blue one. Okay, so I'm just going to underline that in blue. And guys, what else was given here? We know that DE is parallel to BC, right? That's what was given. Just fill that in, please. We're looking back at the top diagram that was filled in originally. That DE is parallel to BC. Just fill that in as well. Now, guys, if we're looking at BDE, the blue one, right? Can we say that DE is the base of the blue triangle? And if we're now looking at the green triangle, can we say that DE is also the base of that triangle? Right? So they have the same bases. Okay. Now, what about the perpendicular height? Do we think these two triangles will have the same perpendicular height? The actual distance between the base and the top vertex. If we're looking at the blue triangle, the base is DE, the top vertex is B, right? So if I had to just write it here on the side, right, that will be that perpendicular height thing. What about the green triangle? From DE to point C, won't that be the exact same height? So guys, the reason for that is because these two lines are parallel. And when you learned the definition of parallel lines, what, in grade 6, grade 7, you learned that parallel lines always have the same distance between them. You guys remember that? Okay, they can never touch. They always have the same distance between them. And the distance between these two parallel lines is the perpendicular height of both of these triangles. Okay, so all you actually have to write for this section is that the area of triangle BDE is equal to the area of triangle CDE, which for me was the green one, so I'm just going to underline that in green. Now, it's very important what you write as your reason here. You're going to say it has, or they have the same base DE. And DE is parallel to BC, therefore same height. Okay, so you're not showing any calculations there. You're basically just writing that those two areas are equal, and then your reason is because they have the same base and the perpendicular height will be the same because of those lines. Okay, almost done, guys. Now we're going to go back to that side of the page. Now we're going to say, do you notice that this was the first fraction that we proved, okay? ADE over BDE is that one there. ADE over BDE. Now, guys, because we've just proven that BDE and CDE have the same areas, these two fractions are equal. Okay, so that line is going to be your first fraction equal to your second fraction. So we're going to say triangle area, triangle ADE over area, triangle CDE. Right, these two are equal because it's the same triangle. So your numerators are equal. And then we just showed now that these two triangles have the same in that one. Okay, so that fraction is equal to that fraction. And guys, what did I simplify this first fraction to earlier on? AD over BD. And what did I simplify my second fraction to earlier on? AE over CE. All right, so if these two fractions are equal, their simplified versions are also going to be equal to each other. So now we're going to say, therefore, AD over BD is equal to AE over BD. That is the proof. Nope. I'm just going to write down the written bits. Yes, you'll have to write it down here. Okay, guys, so let's just quickly look at this proof as a whole. To show you what you're going to write down is just the written part. Okay, you're not going to draw these unless, of course, you want to and you have time to and you feel the need to in order to be able to do the proof. But this is all you'll get marks for. So they usually give a mark for, well, they will give a mark for the construction. Okay, so that will get you 1 mark. Written and drawn in. If you just write it but you don't draw it in, you're not going to get that mark. Yes. So you draw the given diagram, you need to draw those constructions in. Okay, so let me just add here to this tick. Construction written and drawn in. So that's quite a lot of writing, guys. So that plus drawing it in is supposed to take you 1 minute, which it probably will take you a bit more just because it's so much. But obviously, it's good if you remember these quickly, right? If you have them in mind. Okay, next up, you will get a mark for that and then that. They'll give you a mark for showing the two areas and then for simplifying. They'll give you a mark for showing those areas and for simplifying. Yes, yeah. Then they'll give you a mark for this whole line, which includes the reason as well. Okay, so unfortunately, you can't just say, oh, nice, these two areas are equal without a reason. You won't get a mark. So this will be we call it SR. I don't know if you guys have seen that in final exams, if you've like gone through the memo. That means that it's a statement and reason mark. So 1 mark if you have the statement and the reason too. And then they'll give you a mark for saying that these two area fractions are equal. Then guys, this is what was required to prove. They'll often give you this. So then you won't get a mark for that. But it's almost like negative marking. If you don't end your proof off with what they ask you to prove, you're going to lose a mark. Okay, so they'll take away like that mark. So how many marks is that? 1, 2, 3, 4, 5, 6, 7 marks. Okay, they might do like a fill in the blank kind of thing where they might give you like some of these parts and you just fill in the message so that it will be there. Yeah, maybe it's a good idea for you guys to just write this proof out once without all the diagrams and without all the like extra bits so that you can just see exactly what you have to write down in a test exam. But guys, yeah, we're going to do a proof with similarity as well, which is going to be a bit strange because we've been working with similarity since like grade 8, 9, but now we need to prove it. But those are the two proofs for the section, and you can probably expect one of those two for your test. Okay. So definitely you are going to have to study this proof for the test. You're going to do the other one tomorrow. Okay, guys, there are 10 minutes left. I was going to start some similarity examples, but I'm not going to do that now. I'm going to give you one more prop theorem question, a nice hard one. Let's see. Let's see. I don't know. Yeah. I should say, but I don't know. I don't think it's bad. Possible that there wasn't a waiver. Okay, let me just quickly get to the and you never Oh, wait. Time out. Don't write this down yet. Okay, yeah, that's fine. Okay, sorry, you can write it down. 3, 1, 3. Okay, guys, this isn't really a hard one. It's just one last question. So do that one quickly. You can finish it now in the 10 minutes, and then you don't have any homework for tomorrow. Do I see you tomorrow? Yes.